Hello everyone, this is homework 28, solving quadratic equations by factoring. So we've looked at factoring for some time now, quadratics, and we know that the standard form is for a quadratic expression is ax squared plus bx plus c, but now we consider an equation by setting that expression equal to 0. And this is just a formality. A, b, c are real numbers. A is not 0, because if a were 0, square root would be gone, and it would no longer be quadratic, because all you would have is the linear term and the constant term. So it would be a linear equation. So examples of some quadratic equations. We look at this, and x squared minus 5x plus 6, or classic quadratic trinomial, certainly looks to be factorable, but note that it's set equal to 0. Here's a couple examples that are quadratic. Again, you could tell it's quadratic because of the squared terms, but they're not set equal to 0. So those are all quadratic equations, and when we do set it to 0, the equation, that's what we refer to as standard form. And standard form is necessary to be able to solve any quadratic equation, because we have what we call the zero factor property. And the zero factor property is just simply that if you have two things being multiplied together, so we just formally say let a and b be real numbers, but if you had any two numbers being multiplied together and their product is equal to 0, then one or the other has to be 0, because if a is 0, then 0 times whatever b is, it doesn't matter, will be 0, so that would be true. Or if b is 0, then no matter what a is, a times 0 is going to be 0. So the important thing, once again, is to make sure that it's written in standard form and we have a product that's equal to 0. So here are some equations that are already factored for us. And what we do is we just simply, this x minus 8 is behaving as our a, and the x plus 7 is behaving as our b, and that's equal to 0. So therefore, we just simply set each one of those factors equal to 0. And a lot of times what people will do is separate those two equations. They're resulting linear equations, notice. So we set x minus 8 equal to 0. Then a lot of times people draw a line to separate the equations, and we set x plus 7 equal to 0. And note that these are two linear equations that certainly we know how to solve. Isolate x by adding 8 to both sides. You don't need to show that step, but that's showing it formally. So x is 8, and here we subtract 7 from both sides to isolate our x, and we get that x is negative 7. So to express the solution, you could do it in a couple different ways. My math lab has you just separate the two numbers by a comma, so 8, negative 7. Or we could actually use the fancy braces and include the two solutions. It doesn't matter what order, but the order that we obtain them, 8, negative 7, we could put in braces. And when we do put them in braces, this is referred to as the solution set. Okay, so when we have a set of numbers that satisfy an equation, we write the solution with braces and separate the numbers by commas. So either way would be appropriate. So here's another example. Again, you just set each factor equal to 0. We use a little line to separate them. So x minus 5 is 0, and x minus 5 is 0. You don't need to show the plus 5, but if you do, that's fine. And so it looks like we're doing the same thing here. And we get x equals 5 twice. So in my math lab, you could just simply state x equals 5 and that would be sufficient. But formally, we say because it occurs twice, and any quadratic equation actually does have two solutions, we refer to this as having the solution of 5 with a multiplicity of 2, meaning that the solution occurs twice. So nothing to really worry about there. That's just extra. Just enter 5 and in my math lab and you'll get the correct solution. Now in this example, you have to realize that 7x is a factor and x minus 4 is a factor. So we set 7x equal to 0 and we set x minus 4 equal to 0. Now to solve 7x equals 0, we're just going to divide by 7. But there's really no need to show that because 0 divided by anything is 0. So we could have been able to determine that by inspection. Just like these equations, when you have x plus or minus a number, you can solve those by inspection. X will just be the opposite. Like for example here, x is going to be 4. You could do that by inspection. But if you show literally adding 4 to both sides, of course that's fine as well. So in terms of our solution, 0 is a solution, so 0, 4. Okay, now we see a couple factors that are a little bit more involved. But notice that each of these factors that we're setting equal to 0, they are linear equations. And this is the two-step process, recall, where we have the x on one side, so we get the constants on the other. So it adds 7 to both sides, and we get 2x equals 7, and the second step is to divide. So we divide by 2, and x is 7 halves. So that's one solution, and similarly, we'll first isolate the 3x by subtracting 5 from both sides, and we get 3x equals negative 5, and then divide. So dividing by 3, get x as negative 5/3. So the solution is 7 halves and negative 5/3. Okay, so that's when the equations are factored for us. So it's just a little practice on pretty much the final steps of solving a quadratic equation. But if they're not factored for us, because we know, basically this came from, for example, a quadratic trinomial that would be of the form ax squared plus bx plus c. So we factored that by trial and error. So that's where that came from. And so that's what we're going to see in these examples. Here's a general procedure. You have to obtain standard form first. So one side of the equation is equal to 0. And again, there's their standard form. Everything on one side, typically the left, set equal to 0. Then we're going to factor. And if it's quadratic, we're going to do the reverse FOIL, trial and error method. And then use the zero factor property, which was what we did above. And then note that once we use the zero factor property, the equation, here's the worst case, basically, is the two-step process for each of them. And the result is two linear equations. Okay, so with trial and error, using the factor method, I might be going off to some scrap paper to show the factorizations, but note that this is already in standard form, and we know that this came from the product of two binomials, and since the leading coefficient is x squared, the first term of each of those binomials is x, and note that the sign in each of the terms of the binomials has to be positive because the constant is positive. That means the signs are the same, and the linear term is positive, so that means everything's got to be positive. And then we're basically just looking for two numbers that multiply to give us 30, that add to give 11. And that would be 5 and 6, 6 and 5, however you want to write it. And what you could do is, if you have trouble factoring, just take it off to the side. So I've got some scrap paper here. And do your little check. This goes plus 5x, plus 6x, that's 11x positive, which checks. So once you complete the factorization, then we could use the zero factor property. So we set x plus 5 equal to 0. Again, common practice is to draw a line to separate the two linear equations. And we set x plus 6 equal to 0, and then solve these either by inspection or showing it literally as I'm doing. So x is negative 5. Here we're going to subtract 6 from both sides, and x is negative 6. So to summarize the results, again, you could say x is equal to negative 5, comma, negative 6. Okay, here's just another example for practice. And once again, we'll reverse the FOIL method. Make sure you state it's equal to 0. And these are the easy ones when the coefficient of the x squared term is 1, because all we have to do is put an x and an x. Okay, with regards to the signs of the terms in the binomials, we know that they're opposite because the constant term is negative, so the only way to multiply the last terms to get a negative is if we have opposite signs. It could be plus minus, minus plus, doesn't matter. But now let me get some scrap paper and try this out. Okay, we're going to have x plus something, x minus something. If you wanted to, as we've done in the past, you could list factors of the constant term. So factors of negative 10 in this case are 1 negative 10, negative 1 10, 2 negative 5, negative 2 5. Looks like that's it. And the pair that adds to give us negative 3 is the 2 and the negative 5. So with the positive we put the 2, the negative we put the 5. You can perform the check. 2x, negative 5x, combined to give negative 3x, and that checks. So once you complete the factorization, we have x plus 2, x minus 5, then it's the zero factor property. So set x plus 2 to 0, set x minus 5 to 0. Now if you could just tell even by inspection that here x would have to be negative 2 and x would have to be 5, that's fine. But I'm showing obviously the steps literally where we show the zero factor property. And again, you could show subtract 2 from both sides in this case, or just solve it mentally. Similarly here, add 5 to both sides, or solve it mentally. And so to summarize, x is negative 2 and positive 5. Okay, so we've got a couple more to practice. And for question number 3, it's again already written in standard form. So, and the leading coefficient is x. So we're going to have two binomials. First term of each is going to be x. Now the signs again are opposite because the constant term is negative. So one of them positive and one of them negative. It doesn't matter which one. Now let me break out some scrap paper and remind you of a few things. One thing I wanted to do with this one, you could list the factors like we did in that last example. Hopefully you like the trial and error concept. But let's say I look at this and I guess, without listing the factors, I just proficiently guess at 8 and 5, right? Because a lot of times, as we've seen, especially if this middle number is not a big number, it's probably not going to be 1 and 40 or 2 and 20, right? In terms of the factors. So I'm going to kind of split it down the middle and go with 8 and 5. And then let's imagine I put the 5 here and the 8 here, the 5 with the positive and the 8 with the negative. When I perform the check, I get positive 5x and I get negative 8x, which combine to give a negative 3x. So that's wrong. So therefore, what we're going to do is just switch the signs between the two terms in the binomial. So if I switch them, make it x minus 5 and x plus 8. Okay, we've seen this in the past. I just wanted to remind you of it. But now, because if we get the opposite, we get the magnitude right, the numbers right, but the sign is wrong. I'm looking for a positive 3, not a negative 3. And then, so if we switch the signs, then we get it, right? We get a negative 5x for the inners, positive 8x for the outers, and there's positive 3x, so it checks. So, again, the order doesn't matter. I've got it written as x minus 5 and x plus 8. I could write it here as x plus 8, x minus 5, but it does have to be a negative 5 and a positive 8. Okay, so either order. Alright, and then once we have that, that's our zero factor property again. So 1 to 0, so x plus 8 is 0. Use a line to separate the two solutions. X minus 5 is 0. Solve each linear equation. Subtract 8 from both sides here. We get x is negative 8. And add 5 to both sides here. And we get x is positive 5. And when you list your answers as well, it doesn't matter what order. Negative 8, positive 5, negative 8. It won't make a difference. Alright, first thing to notice about this one is, again, it's quadratic because of the squared term. Second thing to notice, it is in standard form because it's set equal to 0. But then the third thing to notice is that it's special. And it's special because it's quadratic, but it only has two terms. And remember, whenever we see a quadratic equation or a quadratic expression, however you want to think of it, with just two terms, the middle term is missing, the x term is missing, then we have to think of the monumental formula for the difference between two perfect squares. That is, a squared minus b squared is a minus b times a plus b. And note that that fits the form. Perfect square of x squared is x, perfect square of 25 is 5, and we have a difference. So hence the name, once again, the difference between two perfect squares. So you could jump right in and factor that easily. X minus 5, x plus 5, set equal to 0. and perform the check if you want to go through it. Got scrap paper here to do so. So set each factor to 0. Oops, I didn't want to do that. I just wanted to check it. Sorry. We'll solve the resulting linear equations after our check here. So minus 5x plus 5x for the outers gives 0x, and it checks. Okay, so then set each factor to 0, 0 factor property again. X minus 5 is 0. Separate the other linear equation with the line there, and solve each one of these. So we get that x is 5, and subtracting 5 from both sides here, get that x is a negative 5. So the solution 5 and negative 5. Okay, so in order to be able to use the 0 factor property, note that we had to have a product of two factors set equal to 0. And that is what we call our standard form. So in order to solve, we have to have the equation first written in standard form. So note that in number 5 here, the equation is not written in standard form. That is, you've got the squared term and the linear term on the left, but the constant term is on the right. So therefore, what we're going to need to do is set this equal to 0 by transposing this constant term to the left-hand side. Now, you could show that in one of two ways. You could show it literally, and I'm going to break out some scrap paper for this because I'd like you to be able to consider doing this mentally. If you show it literally, that's fine. You would subtract 20 from the right and subtract 20 from the left. And then on the right you get a 0. That's why we did it. And then on the left you can't really combine anything because nothing is like. That is, you have a squared term, a linear term, and a constant. So therefore you would just rewrite it as such. Squared term, x squared, linear term next, minus 8x, and then the constant, minus 20. So if you have to show it that way, that's fine. But I'm going to suggest that you consider just a mental transposition by using a little arrow, indicating that you're moving that to the other side. So then it becomes x squared minus 8x, and whenever you move something from one side of the equation to the other, remember what you're doing is really adding the opposite. Or in this case, since it was a positive 20, moving it to the left-hand side, I'm subtracting 20, just like we did literally. And then that's set equal to 0. Okay? Or, actually, let me squeeze it in and show it here. If you have x squared minus 8x, I'm going to do the same thing I did on the scrap. Subtract 20, subtract 20. But then once again, we can't combine, so x squared minus 8x minus 20, and that's equal to 0. Okay, so whatever way you wanted to show it, in the future, I'm just simply going to be using the transposition arrow. But then we have the quadratic equation written in standard form, and so therefore we can factor as the product of two binomials, set equal to 0 again, and because the first term is just x squared. The first term of each binomial is going to be x. And then we're basically just looking for two numbers that multiply to give negative 20 that add to give negative 8. Now, again, you could use any method you like. I like the trial and error, as I've said many times. If I'm going to use trial and error, maybe I check for the signs next. And I know if this constant term is negative, that these are opposite signs. One is negative and one is positive. And then I'm looking for two numbers that multiply to give negative 20 that add to give negative 8. And so let me get some scrap paper here. X minus something, x plus something equals 0. Let me just remind you of all the methods. You know, probably not guess 1 and 20, right? If you did, maybe somebody would go with 5 and 4, because they often say split it down the middle in a sense. That doesn't work, right? This would be negative 1x. And even if we switched the 5 and the 4, it wouldn't work. It would just make this a positive 1x. So that's not it. So then let me guess again. So I'm going to use trial and error again. So 1 and 20 is probably a silly guess. Because otherwise that middle number would be, this middle number that is, would be like either a 19 or a 21, and it's obviously not. Okay, so it's probably going to be 10 and 2. Let's say I put the 10 with the x, that's positive here, and the 2 over here. That gives negative 2x, positive 10x, which is positive 8x. Sign's wrong, so switch the signs between the two terms in the binomial. That is, make the 10 negative and the 2 the positive. And then it works because, and we could show that, of course, by checking. And got a negative 10x and a positive 2x, which combine to give us the negative 8x, and it checks. Similarly, let me just show this again as well. Could have listed the factors of negative 20. So they'd be 1 and negative 20, negative 1 and 20, 2 and negative 10, negative 2 and 10, 4 and negative 5, negative 4 and 5, and then we're looking amongst the list for the pair that adds to negative 8, and that would be the negative 2 and the 10. Oh, I'm sorry. Positive 2 and negative 10, because we wanted a negative 8. And that's what we've successfully done by the trial and error method. So, again, your choice in terms of how you want to go about the factoring. But once it's factored, set each factor to 0. So x minus 10 is 0, and x plus 2 is 0. Then we solve each of the resulting linear equations. For this first one, we just add 10 to both sides. We get x equals 10. And for the second one, we subtract 2 from both sides, and we get x is negative 2. So again, summarizing the solution, 10, negative 2, negative 2, 10, either way is acceptable. So either order, it doesn't matter. Okay, here's another one where, again, it's not in standard form because you have to always set one side to 0. So when we set to 0, we're just transposing, okay? And remember, it's just moving a term from one side to the other, and you're adding the opposite. So this 64, I'm just going to show from now on the transposition mentally with these little arrows. So the x squared on the left now is joined by a negative 64. And that's set equal to 0. And again, if you want to show it literally, you have x squared equals 64. You subtract 64 from both sides. But then you cannot combine the x squared and the 64, negative 64 that is, because they're not like terms. So you get x squared minus 64 is 0. Okay, so whatever way you want to show it algebraically. But then notice in this equation, it's kind of like number 4 above, right? Where we're missing the middle term now. And we think immediately difference between squares. And we see x squared has a perfect square of x. 64 has a perfect square of 8. So set it up for the factorization. X and x, 8 and 8, 1 negative and 1 positive. And then we set each factor to 0. By the zero factor property. And then we solve for x. In this case, we're adding 8 to both sides. So x is positive 8. And in this case, we're subtracting 8 from both sides. So x is negative 8. So again, summarizing the solution, x equals 8 and negative 8. Okay, so we've got a bunch more examples and a couple other important concepts, but I think I'm going to cut the video short right there, and we'll do a part 2 for homework number 28, and so we'll see you when you are ready.